Now let's talk about how to get started with real-time intelligence in Microsoft Fabric. If you'd like to follow along, please see the link shown here. In this section, we'll focus on the real-time intelligence features of Microsoft Fabric to explore how you can build real-time data analytics solutions with minimal coding that can scale to huge volumes of data from a diverse range of sources. Specifically, we will talk here about real-time analytics concepts and explore core components of real-time intelligence in Microsoft Fabric. Most modern data analytics solutions enable two common patterns for data analysis. Number one, batch data analytics. This is where data is loaded into an analytic data store at periodic intervals as a batch operation, enabling historical analysis of data from past events. And two, real-time data analytics, where data from events is ingested in real time or near real time as events occur in a stream of data that can be analyzed, visualized, and used to trigger automated responses. Batch data analytics is generally well understood and is commonly implemented using data warehouse or lakehouse architectures. Real-time analytics may be considered a more specialist option, but increasingly it's being incorporated into large-scale data analytics solutions in the form of a Lambda architecture that combines the periodic loading of batch data for historical analysis with the ingestion of streams of real-time analysis. Microsoft Fabric provides capabilities for both batch and real-time analytics. Real-time data analytics is commonly based on the ingestion and processing of a data stream that consists of a perpetual series of data, typically related to specific point-in-time events. For example, a stream of data might contain details of messages submitted to a social media microblogging site, or a series of environmental measures recorded by an internet-connected weather sensor. The data in the stream can be used to create real-time visualizations for monitoring purposes, or even to trigger an automated action if certain conditions occur. Another example, a stream of data from an environmental control sensor in an office building might enable heating and air conditioning systems to be controlled dynamically to optimize comfort and cost. The data can also be persisted in a data source and queried later, enabling analysts to better understand change over time. Another example, a marketing organization may perform sentiment analysis on social media messages to see if an advertising campaign results in more positive comments about the company or its products, or an agricultural business might monitor trends in temperature and rainfall to optimize irrigation and crop harvesting. All of these scenarios and more can help you get the most from your streaming data. Let's talk about some common goals for real-time analytics, which includes analyzing data to identify issues or trends, understanding system behavior for future planning, and triggering actions or alerts based on specific events or thresholds. Let's note, too, the process here on the right. Stream processing solutions for real-time data analytics typically exhibit the following characteristics. Data streams are unbounded, with data continuously added. Data records typically include time-based information. Aggregation is performed over temporal windows, such as per minute or per hour. Process data supports real-time automation or visualization and can be stored for historical analysis, often combining both approaches. Many solutions combine these approaches to support both real-time and historical analytics. Fabric's real-time intelligence solution provides an end-to-end streaming solution for real-time data analysis across the Fabric service. Real-time intelligence delivers high performance for data for various sizes ranging from a few gigabytes to several petabytes. It can handle data from different sources and in various formats. Fabric's real-time intelligence workload can be used for solutions like Internet of Things and log analytics in many scenarios, including manufacturing, oil, gas, automotive. Using the Microsoft Fabric real-time intelligence, you can create an event stream to capture, transform, and ingest real-time data from various streaming sources. Storing captured real-time data in an event house, which includes one or more KQL databases. Querying and analyzing data in the event house by using KQL queries organized in a KQL query set, visualize real-time data in real-time dashboards, and by using Power BI. Lastly, you can configure alerts that use Activator to trigger automated actions. Notice our diagram on the right shows the ingest and process done in Eventstream, while analyzing and transformation is done in the event house utilizing the KQL query set and real-time dashboard. Lastly, visualization and activation can be done in Power BI and Activator. Real-time intelligence is in the Real-Time Hub in OneLake. The Real-Time Hub in Microsoft Fabric enables seamless data integration by centralizing data ingestion, processing, and analysis in real time, ensuring users access current information. It supports high-speed data processing with advanced algorithms and optimized infrastructure, allowing rapid transformation of large data volumes for immediate insights. Users can continuously monitor data streams via intuitive dashboards and real-time analytics tools, providing live updates and visualizations to detect anomalies, track metrics, and make informed decisions. The Hub integrates with various data sources, including databases, cloud services, Internet of Things devices, and third-party APIs, consolidating information for effective analysis and reporting. It enhances team collaboration with shared workspaces, real-time data sharing, and collaborative tools, fostering teamwork and accelerating decision-making. Security features ensure data protection through robust encryption, access controls, and compliance with industry standards, safeguarding sensitive information. The Hub offers scalability for growing data needs with a cloud-based infrastructure that adjusts resources dynamically, handling increasing data volumes without compromising performance. It provides real-time analytic capabilities to complex queries and instant insights, essentially for applications like fraud detection and operational monitoring. The Hub supports machine learning model integration, enabling predictive analytics and AI-driven solutions, enhancing actionable insight from real-time data. It aids data-driven decisions with comprehensive tools for visualization, reporting, analysis, and empowering users to interpret data effectively and make informed choices. Eventstreams in Microsoft Fabric support a wide range of data sources, including external services like Azure Storage, Azure Event Hubs, Azure Internet of Things Hub, Apache Kafka Hubs, Change Data Capture or CDC feeds, interrelational database services, and others. Another data source is Fabric events, such as changes to items in a Fabric workspace, data changes in OneLake data stores, and events associated with our Fabric jobs. The data source can also be sample data, which includes a range of samples that can help you explore real-time analytics scenarios in Microsoft Fabric. Next, note the different types of data transformations. You can transform the data as it flows in the event stream, enabling you to filter, summarize, and reshape the data before storing it. This is available through transformations that are included here, like filter transformations to filter events based on the value of a field in the input. Depending on the data type, number, or text, the transformation keeps the values that match the selected condition, such as null or is not null. The Manage Fields transformation can be used to add, remove, and change data type, or even to rename fields coming in from another input or from another transformation. The aggregate transformation can be used to calculate an aggregate, things like sum, min, max, average, every time a new event occurs over a period of time. The group by transformation can calculate aggregations across all events within a certain time window. You can group by the values in one or more fields. The union transformation can connect two or more nodes and add events with shared fields with the same name and same data type into one table. Fields that don't match are dropped and not included in the output. The join transformation can combine data from two streams based on a matching condition between them. Now let's look at the data destination in Eventstreams. You can load the data from your stream into the following destinations. Use the event house as a destination lets you ingest your real-time event data into an event house, where you can use Custom Query Language or KQL to query and analyze your data. Using the Lakehouse as a destination gives you the ability to transform your real-time events before ingesting them into the Lakehouse. Real-time events convert into Delta Lake format and then are stored in the designated Lakehouse tables. Using the derived stream is a destination that can be used to redirect the output of your event stream or another event stream. The derived system represents the transformed default stream following stream processing. Using Fabric Activator as a destination lets you directly connect your real-time event data to a Fabric Activator, which is an intelligent agent that can automate actions based on values in the stream. And lastly, using a custom endpoint as your destination, you can route your real-time events to a custom endpoint. This destination is useful when you want to direct real-time data to an external system or custom application outside of Microsoft Fabric. Event houses are where you store real-time data, often ingested by an event stream and loaded into a table for further processing and analysis. Within an event house, you can create KQL databases, which are real-time, optimized data stores that host a collection of tables, stored functions, materialized views, and shortcuts. You can also create KQL query sets, which are collections of KQL queries that you can use to work with data in your KQL database tables. A KQL query set supports queries written using the Custom Query Language or KQL, and it is a subset of the T-SQL language. To query data from a table in a KQL database, you use the Custom Query Language, which is used to write queries in the Azure Data Explorer, Azure Monitor Log Analytics, Microsoft Sentinel, and Microsoft Fabric. KQL is a read-only request to process data and return results. KQL queries are made of one or more query statements. A query statement consists of a table name followed by one or more operators that take, filter, transform, aggregate, or join data. KQL is optimized for querying large volumes of data, particularly with time-based elements. So it's a great fit for real-time data analysis. However, many data professionals are already familiar with SQL syntax. So KQL databases in event houses support a subset of common SQL expressions. You can also use the -- to indicate that you're going to use T-SQL, and then write your T-SQL, and then use the word explain to translate your T-SQL to KQL. It's pretty handy. Microsoft Fabric also includes Copilot for real-time intelligence, which can help you write the queries you need to extract insights from your Eventhouse data. Copilot uses AI to understand the information you're looking for and can generate the required query code for you very easily. Real-time dashboards provide a way to pin data visualizations to a single visual interface, enabling you to surface the real-time insights at a glance. Each tile in a dashboard shows you different information based on the KQL query that extracts real-time data from tables in the Eventhouse. You can create a real-time dashboard as shown here on the left in the workspace and then configure its source, or you can create one directly from the KQL query set in the Eventhouse. Dashboards are composed of one or more tiles, each containing a visualization based on a KQL query expression. By default, the visualization shows the results of the query as a table, but you can edit the tile to customize how the data is displayed. When published, the tiles enable users to explore data that contain interactivity by drilling into the data and using a visual interface to filter and aggregate the data and change the visualization type. Since Power BI is a core component of the Fabric platform, you can also visualize data in a KQL database as a Power BI report, as shown here on the right. Activator is a technology in Microsoft Fabric that enables automated processing of events that trigger actions. For example, you can use Activator to notify you by email when a value in an event stream deviates from a specific range, or to run a notebook to perform some Spark-based data processing logic when a real-time dashboard is updated. Activator operates based on 4 core components: events, objects, rules, and properties. Understanding these 4 principles enables you to utilize capabilities of Activator more efficiently. Events. Activator considers all data sources as a sequence of events, each representing an observation about the status of a particular object. These events can occur frequently, as with the Internet of Things sensors, or less frequently, such as when monitoring package scanning and shipping locations. Activator's objects can be tangible items like vehicles or packages, or abstract concepts like advertising campaigns or user sessions. When creating an Activator item, you model the object by connecting one or more event streams, and then select a column for the object ID and specify the fields to become properties of the object. Activator's rules are designed to monitor your events and data, initiating specified actions once certain conditions within the events are fulfilled. Activator's properties are beneficial for reusing logic across various triggers. You could, for instance, set up a property on the smart lighting system to track the average brightness levels during the busiest hours of the day. This average could then be used in numerous triggers to correctly tweak the lighting and save energy. An Activator can help you in various scenarios, such as dynamic inventory management, real-time customer engagement, and effective resource allocation in cloud environments. It's a potential tool for any circumstance that requires real-time data analysis and actions. You can use Activator, for example, to initiate marketing actions when product sales drop, or you could use it to send notifications when temperature changes could affect our perishable goods. Or you could use it to flag real-time issues affecting the user experience on apps and websites, or to trigger alerts when a shipment hasn't been updated within an expected time frame, or to send alerts when a customer's account balance crosses a certain threshold, or to respond to anomalies or failures in data processing workflows immediately, or to run ads when the same store sales decline, or even to alert store managers to move food from failed grocery store freezers before it spoils. The options here for use cases are endless. These are just a few of the many ways to use Activator. Now let's get started with real-time intelligence in Fabric. Now let's move into our next demo lab here, and that is getting started with real-time intelligence in Microsoft Fabric. So we're going to start this off by creating a workspace. And we're going to give it a name. We're also going to make certain that we have this set to our Fabric license. And in this section, what we're going to do is we're going to make some event streams, event houses, show you how to do a little bit of querying, make a real-time dashboard, and create an alert. Well, to kind of give you an overview of some of the things you can do here for high availability and working with real-time analytics here inside of Fabric. So what I'm going to do is I'm going to take you into the real-time hub. And this is where you can see any data streams that you currently have. You can see a little bit of information about them here too with the workspace that they're in. And you can kind of get a little sense for what's available out there with streams and data sources. You can connect to Microsoft sources also if you'd like to do that. But in our case here, what we're going to do is we're going to connect to a data source. And we have a number of sample data sources out there that we can use, one of which is the stock market. So you can take a look through the list here. There's a lot to choose from. And we're going to use the stock market as our example right here. Real-time weather kind of sounds like it'd be interesting too. But we will do the stock market to start us off. And our news source name here is going to be stock. And hopefully that won't affect us there. And then what I'm going to do is change the name of our event stream. So we're going to create an event stream and we're going to call it stock data. And that should pick up, too many characters here. I think that underscore or the dash. Actually, I think it's a space. So let me do an underscore right there and see if we can get that to work in. There we go. Okay, so we're going to go ahead and click on Next to set this up as our data source. And using that stock market there, event stream we're going to create. I'm going to click Connect. Now, it's going to take just a moment here, but it's eventually going to give us the ability, once it's created it, to open it up. So I'm going to go ahead and click on Open Event Stream. And when I do that, what you will note is we can see our source, we can see our event stream, but we don't necessarily have our destination here just yet. And this environment looks a lot like the pipelines. So we can see that our data will eventually load in here. It'll give us a little luck, but what we're going to do is we're going to work on the destination. So we want to connect to the stock market, pull it in through our event stream, and then be able to do a few things with it. So I'm going to create the event house. Now I'm waiting just a moment here because yes, the data does come in and you can see it right there. So I do want to prove that we can pull it in. And then what I'm going to do is I'm going to go ahead and make our event house. So I'm going to go over to create, which I don't see here at all, but it may be hiding under the ellipses. There it is right there. A lot of times when it's not pinned to the side there, that's exactly where it's at, is off the 3 dots. And I want to make an event house. So notice all the things that we can create here in Fabric and also in Power BI. But what I want to do is I want to use some of our real-time options that you can see right here, and I'm going to create an event house. And I'm going to give it a unique name. So I'm going to call it our
And this is an event house. Okay, so I'm going to go ahead and create that. And then what will happen is it will open up our event house for us. And we're welcome to it. We can look around a little bit. So it has this little option here where it's telling you a little bit about it. So it's telling us here that this is where we want to begin and add data. So it does create a database here with the name of our event house, the same name. And so if I click next to this, it'll kind of give us a little preview. We can add more databases to this. We can check our storage, make sure we have enough space. We can also, of course, look at our resources and then any things that have happened within, in this case, the last 7 days. So it's just giving us a little preview there. So what we're going to do is we're going to take a closer look here. And now that we have this created, we will also click on this database and see that it has a query set under it. So there's a query set in here. And in this query set, what you will note is it has some pre-created KQL queries that we can use. Now, what you need to keep in mind is that KQL is essentially case sensitive. So you have to be somewhat careful when you work with this, that you're using the right case. Either, do everything in lowercase or uppercase or mixed, but just have some way that you know that you've created your objects and we can be able to call them and query them through KQL. So we're going to come back to this and run some KQL queries as we move forward here. But I'm going to go back to the database for a minute. And I'm going to go ahead and get into get data. Now I can get it from here. I can get it from here. But up here, there's like a little bit of a drop down and I can see different sources to pull into my event house. So local, OneLake, Eventstreams, Azure Storage, event hubs from Azure there, different vendors, pipelines, data flow. I can also get into the real-time hub and pull in from there. But I'm going to pull in our event stream that we made a little earlier. So I'm going to choose that. And what I'm going to do with this is I have my event stream pulled in here. I can see that I can add a table right here. So that's what I'm going to do. I'm going to create a new table for this. And I'm going to click on that. And I'm just going to call the table stock. Then what I'm going to do is make certain this is configured. So we are in, let's see, DP-700 Lab 7. And the event stream that we created is this one here. We made this one a little bit earlier. So I'm going to pull that one in. It gives it a data connection name by default. I can use that. I can change it. It is required. I'm going to click on next. And it's going to take it a moment to go through the inspection here. And we'll see where this lands. We'll just let it think for a moment here as it goes through and tries to get connected to our event stream. And it found our event stream and it found our data. Awesome. So that looks good. We have our data pulled in, or we're going to have it pulled in. It can get connected to it. I'm going to click on finish. And there we go. We're going to have it create the table, create the mapping, create the data connection. We'll just give it a little bit of time to do that. Notice too, it gives us some options right here to explore the results, to undo the ingestion if we made a mistake, let's say, or to create the dashboard. I'm just going to click close for right now. And that should give us some data. So we're here looking at our list here. We've pulled in the data. And what we want to do is we're going to go back and look at our our event stream. So I'm going to click on Real-Time Hub here. And I'm going to go into that event stream we created earlier right there. I believe it's the one. And I'm going to open it and take a closer look at it. And you might notice that now we have a destination. So we have our source, the event stream that's pulling it in, and then our destination. And it's going to show you some of the files down below there too. So that looks good. That looks really good. And then what we're going to do is let's do a little bit of querying against it. So I'm going to go back into the event house. And back in the event house, what I'm going to do is I'm going to go into that query set. And I'm going to ask it about that stock table. So it has IntelliSense. So the moment I start typing a bit, you can see that it's going to pick up stock or anything that begins with ST at that case. And when I do that, I'm going to run this. Now, the KQL syntax is actually a lot slicker, very short, just asking it for the first 100 records there of the stock table. And it has to be in lowercase, the word stock, because that is how the table is also written in lowercase. So we have to be careful with that. Now, what I'm going to do is I'm also going to run a little bit of a fancier option here, ask it for a little bit more detail. And what this is I'm going to ask it to retrieve the average price for each stock symbol in the last 5 minutes. So let me select that. And when I select that, you can see it gives me a result right there. And if I were to run this again, it may change a bit for us. If we do see a change on those values, and it may take a little bit to see some changes in there, but remember that this is picking up the stock as they stock market numbers as they change. So we're going to kind of see that. And I was trying to see if I run it again, if it changes a little bit. Yeah, we might have to wait a little bit longer for that, but you get the idea with that. We're going to turn this into a dashboard. So from right here inside the query set, I can pin it to a dashboard. And what I'm going to do is make a new dashboard. Then I can really call it anything I want to call it, but I'm going to call it stock dashboard. And I'm also going to have it the tile named average prices. So I'm going to go ahead and create that. And once I do that, that's going to open up our dashboard. And the dashboard's pretty slick there. You can see that in just a moment. It's going to set itself up. It's just taking a sec. And then once it's here, what I want to do is I'm going to make some changes to this. So I'm going to change this from viewing to editing. And then what I'm going to do is go into this tile and click on edit. And what I'm going to do is change this out. The table might not be the best way to display this. I'm going to see this maybe in a column chart. And then notice I can set my mouse on it. It has a tooltip. So I can see where that number is at, because it's hard to tell with the bar there exactly what the number is. And then you can do some configuration of the legend and the X and Y axis and the tooltips also. So you have some functionality there, and this looks pretty nice. So what I'm going to do is I'm going to go ahead and apply these changes to the dashboard. And there now I have a dashboard. And if I set my mouse on it, I'm going to refresh it and see if we can see any changes. There we go. Probably a little easier here. Might have to wait a little bit to click it again. But you can see the changes as they occur with that dashboard, maybe a little easier. And while I'm here, I'm also going to create an alert. Let me see if I can click this one more time. Any changes? Okay, there might not be any changes just yet. But you have the option there to do an alert. Now I can click it from here. That's one option. I can also grab it from up top. So this is going to be an alert, and it'll run the query and you can choose the options from the list there. And it's going to be based on checking on each event grouped by, and it's grouped by the symbol. And it's when the average price, and you can pick different conditions, but I'm going to choose the one increases by, and I'm going to say 100. I want this to fire off. So what I'm going to do is I'm going to check out how I could have that happen. And you can see it can send me an email. It can message me in Teams. It could also run a fabric item. And I'm going to put this inside my workspace, the one that I've been using here. And then I'm also going to have it create a new item. And it's going to create a new item. I can give it my own name. I'm just going to go with Activator since it's using Activator. And then I'm going to click on Create. So now we have an alert that we can use. And we're going to wait for it to be created. And we could test this out, of course, and see if we see any changes on it. And then we can open this up right here. And that will take me out to the page for this activator. And I can see other options in there too. But there is my alert. And then it's going to show me what it's monitoring there definition-wise. And you can see where those symbols occur in our list. There is, if we don't have a lot of activity on it right now, but we could get into live feed, analytics, and even a history if this has been running for a little bit. So this is our first introduction here into working with our real-time intelligence in Fabric. And I hope to see you in the next section. More on real-time.
Now it's time for our knowledge check. Question 1. Which Microsoft Fabric real-time intelligence component should you use to ingest and transform a stream of real-time data? Answer: Eventstream. Question 2. Which language is optimized for querying real-time data in the Event House? Answer: KQL. Question 3. Which Microsoft Fabric real-time intelligence component is used to visualize and explore real-time data in tiles? Answer: real-time dashboards. In this section, we discussed what is real-time analytics and reviewed that it is defined as ingestion and processing of a perpetual data stream. We also reviewed the common goals for real-time analytics. Next, we talked about real-time intelligent components like Eventstream, Event House, KQL query set, real-time dashboards, and Activator. We then talked about Microsoft Fabric Real-Time Hub that provides a centralized place for managing real-time data sources. We also discussed the data sources, the data transformations, and the data destinations for ingesting and transforming your real-time data. We talked about how to store and query real-time data using the Event House, the KQL database, the KQL query set, the custom query language, SQL, and even Copilot for AI assistance. We also talked about how to visualize real-time data in real-time dashboards or even in Power BI reports. Lastly, we talked about how to automate actions in Fabric using Activator and its events, objects, rules, and properties. For more information on how to get started with real-time intelligence in Microsoft Fabric, please see the link here.